In this video, we're going to show that one of these things is false. So I'm going to kind of examine where they all are at. So the first one is saying, is the function continuous at x equals 0? Well, one thing to notice is that the only places we're going to really be worried about continuity would be at these breaks here, which is at 1 and at -1. Everywhere else, the function is going to be continuous. So in this case, x equals 0 has to be continuous because it's not at one of those breaking points. Same thing with -2. That one would have to be continuous there. So to test the other ones here, we're going to actually plug in, okay, from both the left and the right. So I'm going to go ahead and start with 1 since that's the one that's on the top here. And notice it has to equal this number here because that is what f of 1 equals -1. Then I also need to prove the right and the left-hand limits. This one's set up a little bit backwards. So this is actually the left limit this time, and this is actually the right limit this time. So the limit as x approaches 1 from the left of -2x plus 1 equals -2 times 1 plus 1, which is -2 plus 1, or -1. And we've got the limit as x approaches 1 from the right of x squared minus 2x, which is going to be 1 squared is 1, 2 times 1, -2 times 1 is -2, so we get -1. So it does look like the limit overall for 1 is -1, which also equals f of 1. So that is a true statement. So hopefully this other one comes out to be false. So let's look at this other one. I know that my overall has to be equal to 3. So f of -1 is equal to 3. So I'm going to start examining so this time this would be the left-hand limit. Let me write that again. This is going to be the left, and this one's going to be the right. So the limit as x approaches -1 from the left of -2x plus 1. So I get -2 times -1 plus 1. -2 times -1 is 2 plus 1 is 3. So that looks pretty good. Now I have to do the other direction. So the limit as x approaches -1 from the right of x plus 5. And I put -1 plus 5. Ooh, that's 4. These are not equal. So therefore the limit does not exist, or it's not continuous there. So that is going to be our false statement.